Hello everyone, welcome all of you to this video uh, introduction of MRI fundamentals. Let's start to talk about overview of MRI first in this week. I will talk about biomedical imaging modalities first. We have four different categories for biomedical imaging modalities. First we have radiographic imaging which has X-ray and CT. So it is about the transmission of X-rays through the body and detection of X-ray on the opposite side of the body. Nuclear medicine includes a planar, scintigraphy, SPECT, and PET scan. So it is about the injection of radio tracer in the bloodstream of the body and detection of gamma rays emitted from radio tracer within the body. And ultrasound is about the transmission of ultrasonic wave towards the body and detection of reflected ultrasonic waves from the body. And the MRI is about placing the body in the strong magnetic field that causes spin system to precise and transmitting radio frequency energy to the body, which causes a magnetic resonance and receives radio frequency energy induced in the body. So we are talking about MRI in detail in this video. So this electromagnetic spectrum of the biomedical imaging modalities. So first the ultrasound has low frequency, which has slightly higher frequency than the frequency that we can hear. And the radio frequency is about 100 megahertz level. It is about MRI, and we have infrared and visible light, which has optical imaging, and then above that frequency level we have X-rays and also gamma rays. So gamma rays are used for nuclear medicine. So these are the electromagnetic wave spectrum. So this portion is wavelength and this portion is frequency. So let's talk about the beauty of biomedical imaging modalities. So first they are non-invasive. So ultrasound and MRI, they are completely non-invasive, and X-ray, CT, SPECT and PET scan. So these modalities cause radiation exposure, but still they are considered non-invasive, and they provide tomographic images. Tomographic means X-ray images, and CT, SPECT, PET, ultrasound, MRI. So they provide tomographic image capability, and X-ray and CT, they provide only projection imaging. So biomedical imaging modalities also provide some certain information beyond anatomical information, which has psychological information, metabolic information, and functional information of our body, especially SPECT and PET and diffusion, perfusion, rated MRI, and functional MRI. So these modalities provide these psychological, metabolic, and functional information of our body. So this information cannot be detected through simple dissection of our body. This is also beauty of biomedical imaging modalities. So we will talk about MRI in this course. Let's start about MRI in comparison with other imaging modalities. So MRI provide relatively high spatial resolution, and it also provide a high soft tissue contrast, and it is also provide tomographic imaging capability. Especially MRI provides much modern tomographic imaging capability because it can scan along any direction. So that is unique feature of MRI, which we talk in detail later. And MRI is completely non-invasive, and also it is a kind of integration on many different imaging modalities like anatomy, physiology, metabolism, and the function. So these information can be scanned or acquired all through within our single imaging modality. So that is unique and a great advantage of MRI. And also MRI has feature called pulse sequencing. So each time sequencing of current in radio frequency coil and the gradient coil, manipulation of these pulse sequences provide various information over our body beyond anatomy, and also a psychological and functional imaging is possible. So which has perfusion, diffusion, tensor imaging, and functional MRI. So these imaging features are possible with MRI. Because of that, MRI research field has growing very fast during the recent year, and this figure show some example of these imaging modalities like perfusion imaging, diffusion, tensor imaging, which provide neuronal fiber information, and also a MR angiography. So this provides ulterior information, and this is venous information. And These are the functional imaging maps, that is the human visual cortex. So this information can be acquired with MRI even without any injection of contrast agent. So these are acquired completely non-invasive. Let's talk about signal source of MRI. So what is main signal source of MRI? Then it's proton, the hydrogen, and then why protons are so important. And then proton behave like tiny magnet. So as shown here, proton rotate, which is called spin angular momentum, and this cause magnetic momentum which looks like a tiny magnet. So each proton look like a tiny magnet. So proton behave like tiny magnet, and 70% of our body consists of water, which has two protons. These are abundant signal source in our body for MR signals, and that's why MRI has been so successful so far. And what other nuclei can be used for MRI? And then these are the list: C13 and fluorine 19 and sodium 23 and octanium 17 and phosphorus 31. And these nuclei can be used for MRI, and the some other which odd atomic number or odd mass number can be used for MR imaging. But these nuclei and candidate actually used for MRI. But most of the cases, if we talk about MRI, more than 99% is about proton. Let's talk about the brief procedure of MRI image acquisition. These MRI machines from the outside viewpoint uses partially sequencing, which has one sequencing of radio frequency coil to create three gradient coil. This time sequencing is repeated to acquire data, and then that compose a two-dimensional or three-dimensional data space called key space. We will talk about that later. And then applying for field transformation to this key space provides MR imaging. This is a very procedure of MR imaging equation. Well, there is a synopsis of MRI. Magnetic means putting a subject in the strong magnetic field generated by the main magnet. So that is about magnetic, and the resonance part is transmitting radio frequency energy to the subject through an RF coil and the turning of transmitter, and then receiving RF signal emitted by the subject another RF coil, while the same RF coil used for the transmission, and that is about resonance. And the imaging part is specially modulated the magnetic field strength to distinguish signals from the different location using gradient coil, and we will talk about that is in later. And let's talk about three major hardware component of MRI. The magnet is about typically superconducting, which is cause magnetic field and radio frequency is transmitted and receiving a signal, and then the cause resonance, and there is set of three gradient coils which has long x, y, and z direction, which provides special information so imaging is possible. Here is schematic diagram of MRI hardware. Outside is about a superconducting magnet, and inside the magnet is three gradient coil along x, y, and z direction. And then inside MR gradient coil, there existing RF coils. Right inside the RF coil exist just like inside the gradient coil, which is pre-mounted on the MRI scanner, and then that is typically used for transmission of signal. And then we use small RF coil for detection of signal. This is typically procedure. This is schematic diagram of MRI instrumentation. So we have main magnet, gradient coil, and RF coil. Pulse sequence generator generates pulse sequencing for applying current to the RF coils and the gradient coil, which can be determined by the pulse sequence generator and the programmer. And then the RF electronics transmit current to the RF coils, and then we detect, and then this signal is modulated by the gradient field, and then that provides special information, and special modulated RF signal is detected through the RF coil, and then it goes through image reconstruction computer, and then we can see the image on the console computer. So this is overall schematic diagram of MRI instrumentation. We will talk about more detail in MRI in next videos. Thanks for watching.